try to actually cut down some part of your image, we mostly do actually create a window, right? So that window is actually the main part of the cropping. Now, in the random space, that how actually we can define the window, and how it can have a relationship with the object that you have in your image. That is actually the discussion can be. We have, you can see here in the content about the algorithms for the clipping. We three of the components that we try to discuss about the clipping, like point clipping, then the line clipping. For line clipping, we know that line consists of many number of points. The two algorithm, that Cohen-Sutherland line algorithm and Liang-Barsky algorithm, whereas the polygon clipping has also two algorithm, Sutherland-Hodgman and Wheeler-Atherton algorithm. Now, we are going to discuss actually about line clipping, that one of the clipping, Cohen-Sutherland clipping, and for polygon, that Wheeler-Atherton algorithm. Just the technique, we have the documents there. For the technique, I'll try to actually discuss about how they can work. Okay. And windowing, whenever we are saying that window that we create in the world coordinate space, whenever we are considering about world coordinate, that x and y coordinate, as you can see that a cropping or clipping window is nothing but that from your x coordinate, that window must have actually a minimum and maximum value. That means actually the range of its actually length, and in the height in the y coordinate, it has actually that y minimum and y maximum. The random object that we have inside the window and outside the window, you can see that especially for the primitives, it consists of actually the points. And whenever you have actually the points, you can check the coordinate of those points comparing with that window. And then actually you can identify whether it is actually inside the window or outside the window. So for inside the window, as you can see that after the clipping, that inside the window, that part actually exists, which is actually following that values in between that x minimum and y x maximum, and y minimum and y maximum. Then only we can actually keep it, or we can retain it. Otherwise, the rest of the content actually can be clipped or removed. Uh, Now in the clipping, as you can see that the following image, where actually we can see the components like line and the points, and how we can actually identify that they are actually inside or outside. So that the points which are actually inside the part of the line as well, that should be actually inside the window. The outside that part should be actually the outside. So if we just consider it, that what it should be, see that P2 is outside the window has gone, that P3, P4, then actually that part of that line P7, P8, that has been gone, as well P9, P10. So this part is actually we have. Now to identifying this one, as you can see that those of those points that you are actually comparing for point clipping, simply to say, uh, those of the points which are having the coordinates that greater than or equal to the wx minimum, that means greater than this part, or less than or equal to wx maximum. So actually less than sorry, greater than this part or less than this part. So that's why x is actually having coordinates value is less than or equal to x minimum, or greater than or equal to x minimum, less than or equal to x maximum. Now this is actually, you see that P10 is actually supporting according to that. But the thing is, you must also have to satisfy or consider. That's why you have an AND option. So this part and this part both you have to follow. Now this is not actually supporting that greater than or equal to y minimum. You see, this is also less than y minimum. That's why this is an outside. But this one is actually greater than y minimum. but less than y maximum. If it is, then only actually those points we can understand should be inside the clipping window and they will be retained. Otherwise, the other points they will be removed. Like this point is actually inside that x, that w x minimum and x maximum, but outside of that y maximum is greater than actually that y maximum, so it is not satisfying this part. Okay, for the same for P2, P7, P8, so that they will be actually removed. As you can see, they don't actually satisfy this condition. For the general, simply to identify for the point clipping, that is fine. But what happens when it is about line? So because line is consisting of points, but always we try to actually consider a line based on actually its endpoints. Okay, try to, because we are talking about the finite line, as it is about a finite space, a window which will actually clip. So the finite line, whenever we think, we need to think about two endpoints. Now the scenario can be like your line inside the actually box, that means the window, so that you don't need to clip it, it will be retained. You have actually some part outside the window and some part inside the window, then you must have to clip at some point. Okay, and the complexity happens when actually both endpoints are outside the window. There also you have two scenario, as you can see. Either maybe none of the part is actually touching that window, but some line is, maybe some part is actually touching the window. So if it happens, then actually what you need to do, we also have to clip it, and we first have to check that how much portion or maybe part of the line is inside the box. That's actually for the line clipping we need to go. So that's why we're going to actually discuss about one of the line clipping, which is we call Cohen-Sutherland line clipping algorithm. It's actually doing through some calculation, we can actually find out which line should be inside and which line should be outside and which part can be inside the window. So the first thing that in Cohen-Sutherland algorithm have been applied is actually your space that has been actually divided in 8 3 that how many 9 of that actually spaces or the region that they have been divided, and according to the region, that some code has been assigned on that. And so that actually what happens, your space especially related with your window, that which will be cropped, on the basis of that, actually that region code are actually defining those spaces that where the line or those points should be. It's a very simple way that region has been defined. You can see my window is actually that 4-bit of that region code. So 0000, my window position, which will retain, the rest will be actually cropped. And then actually I have followed that defining all other actually region through that LRBT, that actually way, that left, right, below, and top, that that is actually the constant LRBT, left, right, bottom, and top. So this 4 of that bit is actually defined from position is 0, 1, 2, 3, 0, 1, 2, 3. So the bit will be taken, that 1 is actually for left is in the 0 position, for right in the 1 position, below should be the 2nd position, and above would be the 3rd position. So according to that way that we take the bit. So for this window, if you consider the left position, you can see that left position is actually the 0 position where I'll take the bit. So it was 0, 0, 0, 0. I have taken now 0, 0, 0, 1 in the left position. In the right position, it's in the 1 position, that is 0, 1. So 0, 0, 1, 0. For bottom is actually or below, that is sorry, for 2, So that 0 1 0 0, so in the second position, so this is 0 1 2, that is the way we count. And in the top is actually the fourth position, so that is 1 0 0 0. So we have got actually that four of that bit by following that LRBT. Now, the other position which are remains, this position, those corner of those four position, you can define that position in different manner. Like this is actually the top position of this one, or this is actually the left position of this one, right? The same way, this is actually the right position of this one, or this is actually the top position of this one. Okay, so the same way for this one, for this one also we can do. Now, the if it is top position for this one, if we consider this position, so top is actually the third position the bit should be. So that for this one, the third position, if we go, so 0 1 2 3, so that means 1 0 0 1, so you get actually 1 0 0 1. Or maybe if we consider the left position of this one, the left position is 0 position for this one, so 1 0 0 then 1, so we get 1 0 0 and 1. Similarly, this one is actually bottom of this one, and if it is bottom, then we get actually the second position, so 0 1 0 1, so we get actually 0 1 0 1. The same way, if we consider this is actually the left of this one, so left is actually that zero position, so that should be 0 1 0 1, so we get actually 0 1 0 1. Similarly, in the same way we can get 1 0 1 0 and 0 1 1 0. So this is the way we have defined that our world actually space into 9 of the region. Okay, and 9 of that region, our main objective is to do that. You can understand now that whenever we have lines, you can see here the lines in different position, that lines endpoints now have been defined what actually it is now in subdivided on that 9 regions. Okay, so this is a problem. Look at in here that we have many number of lines. Now, Quinn-Sutherland algorithm, how actually they can do. They have already started to work for it, that we are going to have actually those regions. So the first thing is you define your region, and according to that, you take actually your all the endpoints to define where actually it is. You can see here that inside that window, those points are actually having that region code is 0000, whereas in the left 0001, the down of that is actually 0101, 0110. The same actually that region code has been applied in here. So the first thing is actually we need to find out that the don't clip situation. Now, what actually does that mean in don't clip situation? As you can see here, that yes, we are going to need it this one. Okay, so that what actually we are going to do, that the same problem that I can see in the diagram here. Uh, the first thing that we are actually doing, that in the first stage, that we are telling you will be clipped, especially the endpoints that we have. On the basis of that, if your x coordinate value is less than x minimum or greater than wx maximum, or that less than y minimum or greater than y maximum. This is your clipping condition, the common clipping condition that you define. Then you are actually assigning the region code. As you can see that we are assigning the region code according to that position LRBT, and on the basis of that we have actually assigned that one. Now after that one, that after this one, that we are actually going to find out the region code actually for all the regions for our lines that has been given. So for P3, P4, as you can see that 001 and 100, 001 and 100, the same way P5, P6, 000, and both are actually 00. So the same way that all the points, they have been defined their region codes. Now the main clipping activity starts. The clipping activity in that step 4, the first one, which is we are calling that don't clip situation. Okay, so the main thing is actually we are saying that don't clip situation is actually what. If the both of the endpoints, okay, our main thing is actually if the both of the endpoints codes are actually 0000, then we consider the line is completely inside the window, so that actually it does not need actually to be clipped. So that out of this all the lines, as you can see, P5, P6, that one is actually only having in the both endpoints are 0000, so that we will keep it. Now that is the first thing that we have find that which we are not going to clip, that is confirmed. So we are not going to do anything for P5, P6, so we will keep it because both of the endpoints are actually 0000. Then in step 4.2 is reject test, and that should be our AND test. First of the operation is AND operation that we are going to actually apply on the endpoints of those lines. Now, if the result comes in our AND operation is 0000, then it will not be clipped. Okay, it will keep it and we will test it further. And if the result is not 0000, that means something comes, then actually we will consider that is completely outside the window and we will clip it or we will remove it. So we are going to do actually that AND operation for P3, P4. So P3 001 and 100, P7, P8, P9, P10. Out of that line, the rest of the line, so 1, 2, 3, 4, 5, 5 of those line, we are doing the AND operation in between their endpoints. And we have found that P3, P4, P7, P8, as we know that AND is actually only you can have one when that is 1 and 1, right? Otherwise the combination for 0, 1, 1, 0 is actually 0 for AND operation. And for 11 and 12, there actually you can have that 1 1, so that you get 0 0 1 0, or this one also have 1 1, so you get 0 1 0 0. So these two line P11 P12, P11 P12, or P13 P14, P13 P14 are completely outside the window, so that it will be rejected or clipped. Now you may say like this is also outside, but it does not actually come after your AND operation, so that we have to keep it for the further actually checking that what it should be. So if the value comes actually your AND operation that not 0000, then that line will be clipped. So this two line has been clipped. Now the three line we need to go for further test. Okay, and our further test will be now OR operation. And in OR operation in 4.3, if the result comes 0000, then what we will do, we will actually will accept it and will tell that it is a completely inside the window. If it is not, then actually we cannot clip it at the very first. We will keep it and we'll go for maybe individual testing for the lines, so that for the further test we have to keep it. But we cannot accept it, we cannot reject it. That is actually the case for if you don't have actually 0000. So the three of that line, the P3, P4, we have the P7, P8, and P9, P10. Those three lines we need to go for OR test now. As you know that OR is actually any one bit is a 1, then actually we'll get 1. So that this P3, P4 we get actually 1001. As you can see, P7, P8 we get 0011, and P9, P10 is 0100. Now none of them in the operation got actually 0000. So that what we need to do, we have to actually test it further for actually further to doing the test. So that's why we need to go for actually the individual further test. that we are calling that processing of lines, neither completely in or completely out. Uh, those are the situation what we may consider. So if we go for individually to check for P9 and P10, so like first we are considering this line individually. What we need to do, we have to check that which endpoint is in outside the window. If it is actually having crossing over like that, we start from there, and then actually we have to check that which point it has been actually crossing the boundary of the window. So we have found, like if we start at P10, from the region code of two endpoints, the line does not cross the other boundary, but it is crossing actually the bottom boundary of the window in P10 prime. Okay, in the P10 prime, which is actually crossing that point is actually having the region code is 0000. Okay, when you start from there, this is a convention. When you actually cross over any boundary, then actually you, wherever you are entering, that region code indicates. So for P10 is this point is actually getting the boundary, that region code is 0000 in P10 prime. So we get P9 and P10 prime, both are actually having that 0000, that region code, so that we can understand that part. P9 and P10 prime, you can see here, they are actually completely inside the window now, so that it is retained. That part is actually retained, the remaining part is cropped. So that is for this line. And then we go for actually say P3, P4. In P3, P4, as you can see, both of the endpoints are actually outside the window. Okay, so that we have to start in the both of the endpoint to check that which region they have actually crossover. So consider that we start with P3, and P3 at point in P3 prime, that actually touched in actually the extended window of the upper boundary. Okay, so that is actually, we can say, P3 prime. Okay, now what should be the region code? The region code should be this one, which is actually, that is 1001, that region code for this one, for P3 prime. The same way, now we start from P4, and the line is actually cross over the left boundary extended part, and that P4 prime is also getting actually code that 1001. So we can understand the actually region code of P3 prime and P4 prime are having same 1001, which is not into the window, so that we can understand this line is completely outside the window, all the part of the line, so that we call it actually it is rejected. So that is actually we are not considering it. And then actually consider the line of P7, P8, and in P7, P8, that we start again with P7, as it is start from that P7. Yes, it is crossing the left boundary in P7 prime, which should be 0000. And when we start from P8, it cross over that right boundary, which is actually P8 prime, which is 0000. So that P7 prime and P8 prime both are actually having that region code 00 and 00, so that that is actually inside the window. So that part we will be retaining. Okay. So that is the way that individually that we have kept. Now these three parts, like P9, P10 prime, P7 prime, and P8 prime, and P5, P6, this is actually the line should be retained, the rest will be clipped. Okay, so this is about actually that Cohen-Sutherland algorithm, the clipping algorithm by those steps, especially the region code basis, and also doing with AND operation and OR operation, right? Do you have any question? This is a very simple process, not that much complex. Anyone have any questions? Are you there? So for polygon, as you can see, again we have to need a window. That window is consisting of a actually 4 lines, and they also have some point, and according to the definition of the window that you can create. Now you see the significance here is actually in your polygon, that cropped part, you are actually having more other point in the intersected point with this polygon, with this actually window, and out of that 4 of the value, right? Earlier we had 1, 2, 3, and 4 of the points can create that polygon. Now that is actually after cropping, is many other numbers have been added, like 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of the point actually are generated now altogether. So this two of this actually window and the polygon, that is actually now a main discussion for the polygon clipping. Okay, another concern for is actually your a polygon is actually having a point or vertices which is actually entering vertices or exiting or leaving vertices. Try to understand. Say like this is an example that we are going to do the clipping, that for Euler-Atherton algorithm. Now, whenever we have a polygon, if we consider this example, that if this is my starting point, then actually I enter into the window. Again, I'm exiting the window, right? Reached in my point. Then again, I'm entering the window and then leaving the window, and again entering the window and leaving the window. This is the way actually it has been moved. Now the polygon has actually the order of direction. Whenever you want to draw, you have seen that in your OpenGL code as well, that for drawing the polygon, the sequence you need to maintain. Otherwise your polygon will be messed up. Like you cannot actually have a sequence. So say like this is A, this is B, this is C, this is D, and D to A again. Then it makes a complete polygons. Now, whatever these points that actually it is creating, so in this point, say like this is the intersection point, say like I, so I is actually entering point. Say like this is J, this point is actually a leaving point because the polygon is actually going outside on that. Okay, or for this one, K is actually entering point, right? And L, this one is actually leaving point, and this one, say like M, is actually entering point, and this one, say like N, that is actually leaving point. So this is the way we need to define first, because we need these points. As you can see that these are the points which are newly created later when you are having actually the cropped part or maybe the remaining part of your polygon. So these are actually, this one is entering vertex, these are will be leaving vertex. Like this way we can define it. The algorithm have some rules on basis of that. So for this case, let us start that maybe this polygon is actually having 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. Okay, so this is the way the order of that we have. Now the polygon, you can see that we have actually defined now in here for the loop, like 0, 1, 2, 3, like this way up to 9 to 0 back again. And the window also actually, that region that we have created for that clipping, that window also have actually like A, B, C, D, and A again, right? So A, B, C, D, and D again, that actually you can see here, this two of the loop. Now what we need to do, this two of this loop, it has actually the intersected points, and those intersected points we will add, and we will add the entire of this relationship. You can see this is actually the relationship, but the intersection we did not actually consider here. Now we will first do the intersection. To do that one, first give it the name of those points, like I, J, K, and L. The four of the points has been intersected here. And if we visually can identify that which part should be kept for this one, is this actually the part, and this is actually the part will be kept. The rest of them will be clipped or removed, right? Now for this intersection, first add I. If I add I, then actually what happens for this polygon, that 0, I to 1, right? 1 to 2, the rest are all same, only here 0 to I. And when we actually add vertex that I, you can see that we have done 0 to I to 1, 1 to 2, 2 to 3, 3 to 4, 4 to 5, 6, 7, 8, 9, and 0. So that the 0 to 1, the directly 0 to 1 has been now breakdown with I has been entering in between. Now, for this is actually for the polygon that we have done. Now, what about that window, that clipping region or clipping window, that is A to I to B, and B to C, C to D, and D to A. So A to I to B, B to C, and C to D. Now we add the L, because according to the order, it's coming, the next point is L. So what actually we have done, 0 to I to 1, 1 to 2, 2 to 3, 3 to L now. Now 3 to L, L to 4 it should be. So that 3 to L, L to 4, as you can see. For the clipping window, A to I to B, B to L, you see that B to L and L to C, and C to D and D to A again. So this is after adding the L. Now adding by K, for that same 5 to K, K to 6 we will get. So 5 to K, K to 6, the others are remaining. For this window, now it will be A to I to B, A to I to B, then B to K, B to K, and K to L now, K to L. So there is a change, as you can see that it was B to L directly. Now it has been breaking down to B to K and K to L. So that it is now B to K, K to L, and L to C, L to C, and C to D, and D to A. And finally that one J, for J adding, that is we know that have to come from 8 to J, okay, and J to 9. And for that J is actually, now it was AIIB, now that IB has been break down to I to J, I to J, and J to B, okay, and then B to K, K to L, L to C, and C to D, and D to A. Now this is actually completely we have done now, that the relationship with these two of the spaces. One is the polygon, one is the clipping region or clipping window, and in between their intersection points, that is actually the loop we have completed, right? Now the algorithm next stage is those defining those intersection points. Already we have defined, this is actually a living vertex I, this is actually entering vertex because it is entering, this is actually living vertex K, and this J is actually entering vertex, which is J. So that we need to define, you can see that this is actually this sky blue color, that one is actually living vertex, that I and K, whereas L and J is actually the entering vertex with this magenta color. Now what we need to do, the rule is actually, if you encounter, now we will travel that for the polygon, and if we encounter any living vertex, okay, if you encounter any living vertex, then you need to, that means actually you are going out, then you need to go for actually right hand side or the clip region. If you actually encounter any living vertex, means you are reaching in your loop that you are selecting, then you are actually reaching in the living one, then you should go in the right hand side on that actually your clipping region. If you encounter, that means you reach in any of the entering vertex, then you go to the left hand side, okay, that means your polygon actually that loop that side. This is the main actually starting. So you must need to start that your any of the entering vertex, okay, we have two of the entering vertex, L and J. You should start actually any one of them, so that actually you start with then actually you check that how far you can get the loop. And as long as many actually entering vertex you have to go for actually that many time. So if we start with this one, say L is one of the leaving vertex, as we know. We start with L. If we go, then the convention says this is actually a entering vertex. Then if you encounter any entering vertex, then actually you swap to the right hand side for sorry, entering vertex, then you swap to the left hand side for your clipping region. Can you hear me now?
Yes, sir.
Yes, I think it was got disconnected maybe, right? Can you see the screen?
Yes, sir.
Yes,
Okay,
sir.
that's fine. Now, have you actually, I'm not sure that how far you have listened, that entering and leaving vertex and their rules. Have you heard by that time? Or it got disconnected? That what should be the rule for if you come to the leaving vertex or if you come to the entering vertex? Can you tell that I have discussed that
So
time? You
we
heard it?
there's a loop, sir.
Yes, that loop that this actually two loop has been now connected with this intersected point, right? And this intersected point or vertex are we are defining that which type of vertex they are. That I is actually a living vertex because 0 to 1 you are going outside of that window, okay? While the L is actually entering vertex because you are entering into that window. K is actually living vertex, you are going out, and J is entering vertex. So we have found like L and J is actually the entering vertex, I and K is actually leaving vertex. Now the rule is if you reach in any leaving vertex, then you have to actually take the way of your right hand side, which is actually the window, that clipping window region. If you actually encounter or reach any entering vertex, then you should go actually your left side, that loop, that is actually the polygon. Okay, that is actually the rule. And your algorithm starts with an entering vertex. Okay, so I am actually starting with L as an entering vertex. Now entering vertex has rule to go on the left hand side. I have actually two way. You can see that from L I can go to C, I can go to 4. So I cannot go to CE at this moment because this is the entering vertex. The rule says you should go on the left hand side. So I go in L4, then 4 to 5, then 5 to K. K is a actually living vertex. Now what I should do? The rule said you can go actually on the right hand side. That means in the clipping region that actually loop. Now from K, there is no way to go on the right hand side. Okay, you see that we have two way. One is actually going to the polygon again. Another one is actually going to that actually intersected point again. Okay, that means loop is going back. That is actually so that we cannot go in that part because it's not allowed to go on the left hand side for leaving vertex, so that I'm going in L again. So I made a actually loop now, as you can see. So L4 5KL, you can see here that L4 5KL. Okay, so you got actually your loop. You have another entering vertex, which is actually J. And again, entering vertex, you must need to go on left hand side. So from J, I go to 9. I could have gone actually the B on that clipping region, but it is not allowed. So J to 9, 9 to 0, 0 to I, a living vertex. So I am allowed actually to go on right hand side for living vertex, but there is no way actually to go in there. There is no actually way, as you can see. So it is going two way. One is that polygon that's returning back, and another one is actually the J. It's in returning back in there. I cannot go actually that part because it's not allowed for the living vertex. So that's why I must have to go in this point, which is J again. So I am getting actually the J9. You can see J9 0 0, then I, and then J back again. So that's actually my another loop that I actually made. So these two of the loop that actually I found will be retained. The other of the portion will be flipped. Okay, so according to the diagram also you can see that these are the two of the loop can be created. Did you get it?